I have the great fortune to talk to you about the difference between average and instantaneous. Now, I'm not really going to talk to you much about the difference. I think for most cases, you probably understand part of what's being stated here, but I want to impress upon you there's some quirky stuff with the word average. So let me first point out that instantaneous means at a specific moment in time. The word instant is in there on purpose. So instantaneous means at a specific moment in time. I think you guys have kind of gotten it in your head to mean like it happens instantly. That's not what this refers to. If I have a graph of velocity and time, no matter what it is, say it's this. Some weird, funky velocity going on. And I ask for the velocity at 4 seconds. Well, I'm talking about this velocity right here. That's the instantaneous velocity. Does this object have that velocity very much or for very long? No. Because I'm asking about a velocity at a specific instant in time. That makes it the instantaneous velocity. What we've been talking about so far this year has been instantaneous velocities. In fact, these relationships, often the final velocity is the instantaneous velocity at that moment in time. So if I say find the velocity at after 5 seconds, and you put 5 seconds in here, this would be the instantaneous velocity after 5 seconds. That's what you would be finding. So far this year, that's really what we've been doing. However, I'll get these out of here because none of this is going to matter. Average is different. So let's speak to average. There is average speed, and there is average velocity. They are not the same, and the one that is generally asked more is average speed, but we need to be aware of the definition for both. So average speed is total distance over total time. And average velocity is total displacement over total time. Bless you. But Mr. Shelton, it seems like they're the same thing. They're not the same thing. You already know that distance and displacement are different. We had some examples about that. However, it's worse than that. And let me explain to you why or how it's worse than that. I want you to, it was in your notes, right? It wasn't very much to write down, but I want to go fast. Imagine you guys got, because I don't like this. Imagine you have this arrangement. A car is driving on a curved road and travels at 15 meters per second for 4 seconds, and then travels at 25 meters per second for 5 seconds, but then drops down to 10 meters per second for 6 seconds. All right? Now, I would be unable to ask you about average velocity as you were told it was a curved road. And we will have no way of knowing the displacement, change in position, because it's a curved road. Follow me? So asking about average velocity here would not make sense. But asking about average speed would be just fine, because the car went some distance. So a problem like this, you would have to figure out the total distance traveled by the car. This is not something that we show up in a motion graph, right? We have a constant speed of 15 meters per second for 4 seconds. How far did they go? 60 meters. Yeah, this one's not super fancy math here. We have a constant speed. You're going 15 meters every second. You do that for 4 seconds. You've gone 60 meters. Simple enough? So can you tell me how far you would go if you're traveling 25 meters per second for 5 seconds?
125.
Thank you. 125 meters. And of course, if you traveled at 10 meters per second for 6 seconds, you would have traveled another 60 meters. Thank you. For a total distance of, looks like 245 meters. And how long did it take for you to do that? 15 seconds. 6 plus 4 is 10 plus 5 is 15. Yeah, 15 seconds. This would be the average speed. Everybody got it? Not terrible? Yeah, I'm going to put a multiple choice question on a test. Like this. Dumb, stupid, simple. I'm probably never going to talk about it again. I might have a homework question like this. Dumb, stupid, simple. But unfortunately, I wish I could say I was done. I'm not. And our favorite thing, a graph, again. But again, don't care. Call me the messenger here. And I would rather talk about anything else besides this, but hey. The car accelerated from 0 to 20 meters per second and did so in 5 seconds, then maintained that speed until the 12-second mark. Now, in this case, I think I could ask for the average speed or the average velocity. You should be identified both. Luckily for us, I think, if you've been paying attention, since all of these displacements are positive, this would be the same distance as the displacement. I don't have to worry about them being different if you're traveling forwards and backwards in the same time interval. But that's not happening here. Could you figure out what the average velocity is over the interval? And if you don't know what I'm asking, I will explain myself. So for this case, I am noticing a discontinuity in the graph. Do you notice it? That's an abrupt change, right? It's a point that has no slope because we don't really know what the slope is there because it changes. Now, the truth is the graph is continuous based on math rules because there is a spot there. I get that. I don't care about math definitions. That's why I don't teach math. You could break this up into 2 areas though, couldn't you? And if you did 2 areas, you could probably figure out how far the object traveled in each of the 2 areas. So 1/2 base times height would probably tell you the area here, wouldn't it? So 50 meters. And I could find the next area, but be careful. I've seen people mess this up. The height is 20. What's the base? 7. There we go. 140 meters here. Total displacement of the vehicle is 190 meters. Total time? I want the person who said 12 seconds earlier to get the right answer here. That's why I chose 12. 12 seconds, that's right, there we go. All right, do we see how this is done? These are weighted averages is all they are. If you learn weighted averages in algebra, same thing here.